Hello everyone, I am Senapati, Assistant Professor of Civil Engineering at Vedang History of Technology. So, we will solve one numerical on Mohr circle. You can see in this question, we don't have the diagram. So, let's just draw the diagram. First, what asked in this question? You can see an elastic body is subjected to tensile stress x in a particular direction and a compressive stress y in its perpendicular direction. So, we will take that x in x direction and y in y direction. Let. So, what it says that tensile stress x in particular direction. Okay, let's x is in tensile direction, right? Another thing is what? And a compressive stress y in its perpendicular direction. So, we can write here sigma x, let it is x and in positive direction, and sigma y, that is y in sigma x, that is tensile. Okay, that's why it is positive direction, and sigma y is negative because it is in compressive direction. So, compressive stress y in its perpendicular direction, x and y are unequal in magnitude. That does mean sigma x and sigma y is not same. Okay. So, on the plane of maximum shear stress in the body, there will be, that does mean there will be maximum shear stress. So, let us just start drawing the Mohr circle. So, to draw the Mohr circle, first we need to plot x and y axis. Okay. Here and here. So, let us just increase this up to this point. Okay. Now what? Now it says sigma x will be in positive side. So, let's this distance up to x. Okay. So, it will be our sigma x, and sigma y is negative. Also, it says sigma x and sigma y is not same. So, this is the sigma y value. Okay. So, now what? Now, we will take sigma x plus sigma y upon 2, and by doing this, we will have our center line or center point. Okay. So, now by taking Cx, we can draw the Mohr circle. Here. Done. So, what it says, on the plane of maximum shear stress in the body, there will be, what will happen? So, we have center point. So, on what point there will be maximum stress? If we draw one perpendicular from this center line, that will be our maximum shear stress, right? Okay. So, here we have in this point what? Tau max, right? So, okay. Now, how to find out stress? That question asked, in that point here, there will be no normal stress or maximum normal stress or minimum normal stress or both normal and shear stress. So, what we will have here? So, you can see in this point we are having tau max, but in first point we are having normal stress. Here in, you know that x axis represents normal stresses. So you can see shear stress and center point. From these to this, there is some values here. From this point to this point, there will be some value. That means there will be some normal stress. Let's take that as sigma n. But so our first point will be neglected. Then that does mean here are some normal stresses. So no normal stress point will be cancelled. Another thing was maximum normal stress. So we know in case of Mohr circle, from this point to this point will be our maximum what? Maximum normal stress, right? And this point, these to this will be sigma n minimum, right? So, but this point is, this sigma n belongs to only this point up to this. So, this maximum normal stress and minimum normal stress will be cancelled out. Now, what we have? Only the point D, that is both normal and shear stress will act here, right? So, this is one 2-mark question. This question contains 2 mark in GATE. Okay. So, in GATE, we will have these type of conditions. We just need to plot the diagram, then we will get the answer. So, let's go to next question. Okay. What it says? For the state of plane stress shown in figure, determine the principal stresses. Finding out center and radius, while sigma x, sigma y and tau is given. You can see here, angle is not given here. So, let's draw. So, we can see sigma x is in negative sign. So, we will take that as compressive, but 8 megapascal, and sigma y is in positive. So, we will take that as tensile stress, and shear stress is given 6 megapascal. So, one will be clockwise and another one will be anti-clockwise sign. We know in case of sign convention, sigma x, that is positive. Okay. So, we will take that, sorry, if this negative we will take in compressive and it will be our tensile. Similarly, in case of shear stress, for clockwise direction we are taking positive sign, and anti-clockwise, or you can say counterclockwise direction, we are taking negative sign. Okay. Now, we need to plot the Mohr circle. So, okay, first thing we need to, as we have already drawn this diagram, let's erase it. Okay, so 8 megapascal in negative sign. So let's take two centimeter as 1 unit. Okay, so here this point is O, or you can say 0, 2, 4, 6, 8, and like this side 2, 4, 6, 8, 10. We are having compressive stress in which direction? In this side. So here we have sigma x and sigma y is 12 megapascal. 10, 12. Okay. So this is going to be your sigma y, that is 12 megapascal. Okay. Next, we need to find out what will be the center line from this. So, as we are always doing sigma x plus sigma y by 2, that does mean let's 12 minus 8 by 2. 4 by 2, that will be 2. So, this point will be our center line. Let's take it as C. So, you can see there will be 6 megapascal here and here. So, in x plane on which x trace is present, we will take that x plane. So, here the diagram represents which direction? It will be your anti-clockwise direction. So, on sigma x there will be what? The shear stress will be negative. Right here. Okay. Similarly, here you in this direction, you can see the whole, yeah, okay, this angle is clockwise. I have done some mistakes here. It will be positive and in y axis here it is negative. Okay, let's join this. After joining this, you can see a midpoint is at same place. Okay, now we need to draw or plot the Mohr circle. Okay, so what will be the value of radius? You can see we have known this value. So, if we add the value of sigma x, if we add sigma x plus c, okay, so we will get the value of radius. So, sigma x is nothing but what? 8 plus this center is up to 2 point. So, radius will be 10 and center is 2. Now, what? Now to finding out center and radius, we have got the value of center and radius. C is 2. So, the principal stresses, in case of if there is the shear stress is 0, so then there will be what? If there will be shear stress is 0, then we can find out the principal stresses. Here we will have sigma minimum and at this point we will get sigma maximum. That will be sigma max, that will be sigma major, and sigma minimum, that will be sigma minor. Those values will be your what? Principal stress values. So what will be the principal stress values? We need to add sigma maximum with up to this point. Okay, we can measure it with using scale and put the values, right? So in this question we have find out the center and radius of those stresses and what are the principal stresses will be present in this case. So we already solved two numericals and two different types of numericals. In our next classes we will solve more numericals and different kinds of numericals. To know that, stay tuned, keep smiling, keep shining. Thank you so much.